good evening, good afternoon, whatever. Okay. So we are live now. Okay. Before starting, students, please participate in this chat box. So I must be able to know that everything is working on good. No, I mean, am I audible? And is the video clearly visible to you? Please participate in this chat box. It's very much important. Okay. I hope you have participated. Let me do this. Yes, myself too. Okay, so you people say here, ki sir, you are audible and your screen is visible to you. I'm ending this and I'm telling true. If you want me to share the results, these are the results on your screen. So you all people have voted, ki sir, I like you are audible and screen is visible. Okay. So I'm not saying simply, I'm not starting the session now, simply without your permission. Got it? So it's there online. Now let us resume to the sharing. Okay. Resume share. Okay. We are starting it, students. Okay. Yes, so it's PowerPoint. I mean, it's full slideshow, full on your screen. You can see yourself. So, students, first of all, we'll revise some things. Hold on one second. Okay. So, see, students. Now, first of all, we'll revise the things slowly, like turtle. Okay, not like a rabbit. So, this is the thing to be revised against. Revision. It's revision. Okay. So first we'll go through the introduction to interference. We'll understand the introduction. Then we'll see understand about coherent and incoherent sources. Then we'll understand superposition of light waves, that how the light waves are superposed. Then we'll understand Young's double slit experiment. Okay. So basically our today's goal is this. I'll put R for the revision and N for the new thing. Okay. So this is R for the revision. This is R for the revision. Again, this is R for the revision, and this is a new thing in front of you. Okay. So are you all ready? Please reply in the chat. See, don't be lazy. Please reply in the chat box. Jane V. Faror students have come. Good afternoon, Jane V. Faror students. Welcome to today's class. How's everything going on? All is well? Okay. So all of you must reply in the chat box. Otherwise, it's like, very, kind of lazy class. So first we'll start with this introduction back again, revision. We have seen all these things. It's better to directly start the animation. Through that, the intro will be very nice. So you can see, first of all, the down is switched on, then the up one is also switched on. So you can see the light rays which are produced by these two are superposing, or there's a superposition of the wavefronts which are produced by these two sources. And these two wavefronts are being superposed and a pattern is being formed on the screen, which you are able to see. Students, observe this experiment very carefully. Observe this animation very carefully. It's very important throughout the chapter. If you just can keep this animation in your mind, all the concepts of this chapter are basically by themselves it's solved. You can derive full mathematics. So this is imagination. The downward is switched on, then suddenly the upward is switched on, and you can see a new beautiful pattern is being made here. And you can see here what is happening. On the screen, the blacky and the brighty bands are there. These are alternate dark and bright bands. Okay. I'm writing here. These are alternate dark and bright, bright bands. Okay, got it? So if you see the theoretical aspect, it says like this. Interference is nothing but basically between two or more light waves. It's just an addition or overlapping, or other word is, physics word is superposition and English word is overlapping of two or more light waves, which results in the new wave pattern. Okay, so that we have seen in the previous animation. So let us see that what is happening here. See, the light rays which are produced by this source and this source, the wavefronts you can say, is what it has been overlapped here, and the pattern you are able to see on the screen. This is dark band, bright band, dark band, bright band, dark band, bright band. Okay, I hope it's clear. Okay, I hope students it's clear. So after this, we have seen conditions which are required strictly for the production of interference patterns. See, to set up a stable and clear interference pattern, two conditions which must be met are these. The waves must be monochromatic. See, mono matlab single. One. These are the words. Chromatic is connected with the wavelength. Okay. So in the bracket, it's already written that they should be of the single wavelength. Second, they say the source must be coherent. Coherent matlab having the fixed frequency and the phase difference to be constant. Having the fixed frequency and the phase difference to be what? Constant. If we understand here coherent sources, so we can say here coherent source are those sources of light which emit waves that have same frequency, as we've already understood. And zero or constant phase difference. Okay. So this is coherent light. Incoherent means what? Matlab, incoherent source means a source that emits waves having random frequencies and phase differences. Okay. Electric bulb, night lamp, etc. Okay, got it? This is what incoherent light. And see, this was the last slide which we have seen in the previous class. Hai na? So in this, what was happening? This is a light source here. And incoherent light waves are being produced from here. And this is specially coherent. Matlab, specially matlab space coherent. So there is a difference in this slide. You know, I've explained the light waves difference. What is it? Here from this light source, the light waves are polychromatic. Okay. But here they are polychromatic plus incoherent. But in the second picture, they are made coherent, but they are still polychromatic. But in this third picture, after using the wavelength filter, they are both coherent, which is the required stable condition, strict conditions for the interference pattern to be observed. Plus with coherency, it is following the property of Monochromaticity. These are monochromatic poles. So this is the condition of the light wave or the light source से जो light is coming for the interference pattern to be observed. Okay. Now, students, this is a question in front of you. Please solve it and answer me. These are the four equations given to you. First equation, second equation, third equation, fourth equation. So you have to answer that which pair of equations, say x, y. X can be 1, 2, 3, 4. Y can be 1, 2, 3, 4, whatever. Okay, 1, 2, 3, 4. One will be fixed. So for that, among these four options, what is the right answer for which the interference pattern will be visible at all times, 24/7? Your time starts now. Okay. Your time starts now. This is the hint for you. Hint is this. Use this solution as a hint. See, this is not a complete solution. This is just a hint. This is for you, what students? It's a hint here. Okay. Use it. Use it as a hint and find the answer of this question. A, B, C, or D. Solve it. Okay. I'll ask you in a minute. What is your answer? Is A, B, C, or D? Okay, let us see the solution. See, there are four equations. What are the equations? 1, 2, 3, and 4. Okay. So if you focus here, these are the four equations. So we'll draw first table, a simple table. Okay. See, this is A option, first and third equation. We know for the equations given of the wave, say vibrations also, if you want to see whether they will interfere or not, what's the eligible condition? Eligibility condition is what? That phase difference must be constant. It must not vary with time. So we'll say phase difference must be constant. It's given by this formula. If there are two vibrations or waves, it must be constant. Matlab it must be not, must be function of time. Okay. So from this we can see these are the equations 1 and 3. Matlab omega 1 t minus omega t, and this is time dependent. So we are actually solving the phase differences. Okay. So you can see first and third equation. First ka omega t, second ka omega 1 t. So minus it will get this. 1 and 4 ka omega t plus del. This is the del answer. Third ka 2 and 3, 2 omega t, omega 1 t and 2 omega t. This will be the answer. Fourth ka third and fourth, omega 1 t and omega t minus del. This is also time dependent. Okay. So we are having three equations, A, C, D. These are all time dependent. Okay. This is time independent. Okay. So we say B14 equation is function of, is not a function of time. Okay. So we can say B option, that is 1 and 4, is time independent. 1 and 4 is time independent. It is time independent. Okay. So by watching, by understanding, by analyzing the phase differences, we can analyze that del angle will go to what? It is constant here. Okay. Constant का मतलब this is suitable for interference. That is B will be the option. First and fourth equation. So theory of interference of waves. This is the first equation. This is a little bit of more understanding from this picture. The theory of interference. This is first equation. This is the second equation. So when both of these will overlap, you get the values equals to y1 plus y2. And the net answer, you know it, will be overlapped. Okay. So suppose this is the first equation A cos omega t. And this is second vibration equation A cos omega t plus phi. When these two waves will overlap, so we'll say like this, net result will be what? Y equals to y1 plus y2. This is the net result. From this, we will take cos c plus d will be 2 cos c minus d by 2 cos c plus d by 2. So this is the net value here. Okay. This will be the net value. So from here, we can see this will give you the capital A value. A is equals to what? It is equals to 2a cos phi by 2. Okay. Remember now, this equation which is in front of you is the superposed equation due to two waves, y1 and y2. Okay. And if you focus here on the amplitude of this superposed interphased equation, if you focus here on the amplitude of the superposed or interphased equation, its amplitude, if you see here, it is what? It is here equals to 2a cos phi by 2, which is phase dependent. Okay. So this is the specialty of this interference wave. Now we'll see some conditions. See, we'll understand the condition for constructive. See, if anybody is having the doubt, no, in between, you reply me in the chat box, okay? Or if you want to write it down and I have skipped it, so please tell me, sir, put the slide back. I want to note it down. It's up to you. Okay, it's like we are flexible here very much. Whatever you want, we will be done. So now we'll understand condition for constructive interference of waves. If you focus here on the condition of constructive interference of wave, constructive मतलब होता है students maximum. Can be like bright color, intensity max, positive, all the words sense of the constructive. So when we say condition of constructive interference, it means when the two waves are being mixed up or overlapped or superposed, they will give you net wave which is the having the maximum amplitude. So this is following the condition of interference of waves or overlapping or superposition of waves. In what sense? In the sense of constructive interference. Okay. I hope it's clear. This is what? This is constructive interference. Okay. Now, students, for constructive interference, intensity should be maximum. I have already told you this thing. For constructive interference, intensity should be maximum. If we know this thing from the lower classes, 11th also, okay, that intensity is directly proportional to amplitude square. And we know now that in this overlapped equation of wave, amplitude here is given by 2a cos phi by 2. Okay. So intensity will come out to be 4a cos square 4 phi by 2. Intensity कितना आता है? It is proportional to this much. So from this we can make a formula which gives you a generalized formula of intensity, which is equals to this. I equals to, what was the next? I naught cos square 5/2. If I want to put this intensity maximum, I can put what value? I naught same. It will give me 1. So for this, I'll get the cos value to be 1. And for cos value to be 1, square value to be 1, cos phi must be 1. But for that, phi angles must be multiples of these. Okay. So from this, I'll get a general phi value. That if the phi value is this, either 0, either plus minus 2 pi, either plus minus 2 and pi. So for this, the condition of constructive interference will be followed. For this, the condition of constructive interference will be followed. That is when the phi value will be 0 plus 2n minus pi plus 2n pi. The condition of constructive interference will be followed. What is it? Either 0 degree, either plus minus 2 pi, either plus minus 2n pi. Condition of constructive interference will be followed here. Okay. And corresponding power difference, it will be equals to K delta x equals to del phi. 2 pi lambda. Delta x is a power difference. Delta phi will be what? You can write it as general angle 2n pi. Delta x equals to n lambda here. Okay. So from this, we'll get a power difference equation. That this is a power difference equation, students, which tells us this thing, that if the power difference is equals to, this is the power difference between the waves. If this is equals to n lambda, then this is a condition of constructive interference. If power difference is equals to n lambda, then this is the condition of, remember, it's the condition of constructive interference. Always remember these things throughout your life. Okay. It's a condition of constructive interference. Now we'll see somewhat theoretical aspect again. So in this picture, you're able to understand, students, that suppose this is a wave and this is also a wave. When they are constructively interfering, okay, we can say here amplitude will be add up, y will become equals to y equals to y1 plus y2. This will give you a in addition with a, that is equals to 2a. Okay. But phase difference between these two will be what? 0, because these are coherent. And power, suppose two waves are interfering, if the phase difference between them is 0 and the power difference is 0 for them, है ना? So we will say there are superposing constructively, and it will be the net answer having the 2 amplitude. For destructive interference, if you focus, intensity should be 0. What's the reason? Destructive matlab like destruction sense, although the war is going on, you know, Russia and Ukraine. But destructive matlab destruction, matlab 0, matlab dark. You can take these sense, dark bands, okay? Because already we have seen in the animation experiment, no, that on the screen different kind of bands were there. Some were darky, some were bright. Some were darky, some were bright. Some were darky, some were bright. Hai na? These are all things we have seen. So this is the equation. I mean, we have seen the intensity equation. What was that? I equals to I naught cos square phi/2. If we want to find the mathematical angles and the power difference corresponding to it, I mean the phase difference and the power difference corresponding to that power difference, phase differences, you have to put the intensity to be under the condition of destructive interference. For the intensity to be into the conditions of destructive interference, intensity must be 0. So for this, cos phi will become 0. Cos phi is 0 on which phi angles? These are the phi angles. If you put phi 0, cos 0. No, it's wrong actually. This is a wrong thing. Cos phi must be not 0. Acha. See, no, it's right, students. By the way, it's 5. 5/2 must be 0. Cos 0 कब होता है? Cos 0 is how much? 1. So we'll say cos pi, if pi by 2 is pi by 2, this will give you 0 cos, hai na? So this will be pi. Actually, the phi angles, see, actually the angle in the cos theta, if the theta is equals to say, pi by 2, 3 pi by 2, then the cos value is 0. But here it is angle ka pi by 2. So we'll compare it with pi by 2, angle ka pi by 2. So this will give you pi and 3 pi values. Okay, so that's why these values are coming. So corresponding power difference with this is equals to k delta x phi angle. Put the general phi value equals to 2 and 1 plus phi. Put this k, which is equals to 2 pi by lambda in the denominator of this. So we'll get the power difference here equals to this much. So the power difference which we am getting, power difference which we are getting here is equals to 2n plus 1 lambda by 2. Okay. So this is the power difference for destructive interference. Remember, it's the power difference of what? It's the power difference of, is the power difference of constructive interference. ठीक है, हो गया? And a little bit of the theoretical picture here is this. Suppose this is a wave here. This is a second wave. And the power difference between these two waves, the points in the waves, the power difference between these two waves, if you focus here, this will be equals to how much? It will be pi actually. And the power phase difference is this. So power difference corresponding, we know the formula. K delta x equals to phi angle, that is pi. So from this we'll get the power difference equals to lambda by 2. And this will be the next picture here. Okay. So destructive interference condition is also completed in front of you, students. Is there any doubt in this? Students, is there any doubt in it? If you're having any doubt, please reply. Students, if you're facing any doubt in this, please reply. You know, the net, see, this is the net result only. The amplitude is 0 here. Okay, why? Why the amplitude is 0? Because plus a and minus a will go to what? 0 only, no? That's why the reason is that. Okay, so you can note it down. If you're having any doubt, you can ask now. I'm waiting for your responses. Again, so students, this is again a normal picture. On the left hand side was a practical animation. On the right hand side is the rough geometrical picture which is been shown in front of you. That when from the two sources, say S1, S2, I'm talking about the right hand side, okay? So when from the two sources S1 and S2, the wavefronts are coming or the light rays are coming. Here it is shown by wavefronts. When they interfere at particular points, you can see the bright and the dark band are appearing. And on the left hand side, it's the real picture, practical picture. Okay. So match both of these, write the equations with that, and then you'll be able to solve. I mean, you will get revised by all those things. Okay. You'll get the revision. Say this, we know this thing for the bright band. For the bright band, what's the condition is? Yeah. For the bright band, the power difference is, I'm writing it again. For the bright band, the power difference is n lambda. For the dark band, the path difference is 2 and 1 plus lambda by 2. Is it right, students? Is it right? Yes. So for the dark band, this is the part difference. And for the bright, this is the part difference. Note it down in the notebooks, okay? So now we'll study the next topic of today's class, that topic double slit experiment, okay? So please draw this picture in your notebooks. It's very important. So if you focus here, what is happening? There is a source of light here. From this source of light, the rays are coming like this, and they pass through this slit. After passing through this slit, the rays are coming here, okay? Suppose the light here was incoherent. So after passing through the slit, it becomes coherent. Then there is a double slit. After passing through that, when it is taken up on the screen, we are able to see alternate dark and bright bands. We are able to see alternate dark and bright bands. Okay. Here we can see that slit size is in the order of the wavelength of the light. Remember this thing also. The slide of the slit must be in the millimeters. It's very small. Okay. So this is complete setup of the Young's double slit experiment. Actually, you will find this thing that is very similar to the interference pattern. That there is a light source, the light rays are coming, and it passes through this, and it is actually okay. So Young's slit is nothing but interference of two waves which are segregated from the complete source of light after passing through this double slit or double gap or cardboard kind of thing. Okay. So this is the picture which you're able to see on the screen. Now please note down this mathematics and then I'll explain you something easy. Okay. So suppose this is a source of light and these are two slit gaps. And these two slit gaps are at d distance, small d. And the screen is placed from the sources of light at a capital D distance. And when these waves are interfering there, okay, these are the position of the wave in interfering, okay. So we'll find this y, that what would be y for bright and what will be y general formula for dark. This will find because questions to you in the exams will come which are based on these formulas, okay. Please note this down, note it down and make it. I'll be again I will proceed towards the next slide within 4 minutes, 3 to 4 minutes, okay. So note it down, you're having enough time. Please, this is a derivation, please note it down. What is happening here? Everything is given already in the screen. First draw this. I'm giving you 2 minutes for drawing it properly, okay. Draw it. Okay. So watch it carefully, students. Now we'll see something. See this S1P. I hope you have drawn all the things. Okay. So I've given you enough time. Enough time was allotted to you. This S1P is the wave passing from this S1 slit. This S2P, S2 say P is also the second wave. If you see the phase difference between these two, sorry, the path difference, these lengths from S1 to P and this point to this point, these are the same in the lengths. This and this are same in the lengths. Okay. And the remaining gap, if you see here, this d sine theta is equals to dy by d. Okay. Actually, see, this is a second trick to solve this part difference. But if you focus here, this is S2P. Okay. The property used here is we'll take some triangle and that will do hypotenuse square is equals to base square plus perpendicular square. Here is some other triangle. In this, you also see hypotenuse square, base square equals to perpendicular square. Okay. And through this, you'll get S1P here. This is S2P square minus S1P square. Finally, from this, you'll get the part difference is equals to this. See what it is explaining you? It explains you this, that this Y factor, if you want to see that where is the maximum and where is the bright band, where is the dark and where is the bright band. So I'll be able to watch it carefully. Okay, see. Y equals to del capital D upon D, part difference. I know for the bright band, see, just leave the derivation, just focus on the main formula. I know for the bright band, the part difference comes out to be n lambda. Okay. And for the dark band, the part difference comes out to be how much? We know the formula 2n1 plus lambda by 2. So if I'm putting here this, and with respect to n1, n2, n3, these all values, I'll get the y locations, y heights from the center of what? The bright bands. Similarly, if I put here this part difference in this formula, and then corresponding to it, the different n values 1, 2, 3, I'll get the part differences, I'll get the y distance of what? Different positions of the dark band there. Okay. So students, if you focus on the position of the bright band, this is on your screen. Write it down, this chart. If you focus on the position of the dark fringes, write it down. This is on your screen again. Okay. So actually that formula gives you the position, the locations of bright fringes. See, हमने देखा ना screen पे. We have seen that on the screen. No, leave students derivation now. Don't forget it. Okay, if you're feeling it like kind of cheesy. I mean, it's like complex, irritating sometimes to some students. Okay, so what happened? This is source of light. This experiment you're able to see. No, suppose this is central point. Say y equals to 0. If I proceed here with increasing y, a different position, you can see that if I go somewhere from y equals to 0 to this point, or say this point, here is black band, then again this, there is some bright band, then again this dark band, bright band, dark band. So I'm starting from y equals to 0 with increasing position, with increasing length and height. If I keep the screen vertical, turn it vertical, this will be height. Okay. So the thing is this, with increasing y distances, you can see here what is happening. With increasing y distances, we're having here, as this y distance is increasing, there are the bright fringes here. As this y distance is increasing, there are the dark fringes here. ठीक है? Is it done, students? Okay. So write this formula. That's very important. This will give you the position of the bright band. This will give you the position of dark band. Now we'll see something last thing of the class. That is fringe width. Suppose, students, this is the pattern which you're able to observe on the screen. Okay. Suppose you take a white light. Oh, sorry, a yellow light. Okay. So you will see the yellow bright. You will see the yellow bright spots there. You'll see the yellow bright spots there, and you'll see the dark bands there. This is a yellow bright spot there, dark bands there. Yellow bright spot there, dark bands there. Yellow bright spot there, dark bands. Yellow bright spot there, dark bands. Yellow bright spot, dark bands. Okay. Something known as fringe width. What is this? It's bright. It can be dark. It can be bright. Let us see the fringe width. Actually, it's the gap between one and the next band. Okay. So if you see here, suppose I'm taking at the Y position some band like this. This is the band. And at some n1 position, this band. So these are two dark bands. For the dark band, you know the power difference formula 2n1 plus lambda by 2. Okay. So if you solve that formula, this will be the formula. Put n simple 2n plus 1 lambda by 2. And I mean, for that Y distance. Okay. And this is for the n minus 1 distance. So ultimately, you'll get the band, the fringe width. I mean, the gap between these two. N and n minus dark. See, you might get confused. Ki, sir, ye dark ke liye hota hai? No, it's not for the dark. It can be bright. For the dark, it is given. You have to put the values n into n minus 1 in the formulas. In which formula, sir? The formula is this. Suppose I take the position yn 2n plus 1 this is d lambda by 2d. Then I take the position of n minus 1. So when I put n minus 1, this will be what? क्या होगा n minus 1 2n minus 2 2n minus 1 will be the next. If you subtract these positions minus this position, you'll get the values equals to simple, which is given on your screen. The next this. Okay. So this beta factor is known as fringe width, and it is proportional to the distance of the screen from the slits and inversely proportional to the distance of the distance between the slits. Okay. And this is the expression for the dark fringe here. Difference in position of the nth and the n minus 1th bright fringe. See, this previous was the dark fringe, but this is for the bright fringe. We know for the bright fringe, delta x power difference must be n lambda. And we know this thing, the y, okay, y value must be what? Actually, it must be any one of you. Y value, if you see in the formula, see this, it's n d lambda by d, okay? So y distance, y position of the bright fringe from the center will be n lambda. It's like this. Hold on. We'll say here, it will be equals to n lambda capital d by d. So here we'll put yn minus yn minus 1. Okay. This will be n lambda d by d minus n minus 1 lambda d by d. So net answer which we'll get is this, capital D lambda by d, which is the fringe width. Okay. So expression for fringe width is that the fringe widths are equally spaced on the screen. This we can see, na? I mean, either you take the bright fringe width, which is given by this formula. Either take a dark fringe width in the previous slide, which is also given by the same formula. So these are same. Okay. Remember this. Why we see then bright and dark? Because for the bright, the location we are taking with the different multiples n and n minus 1, I mean, side by side, the formula is this n d lambda by d. But for the dark, the y positioning, the y position general equation is n, it's 2n 1 plus, it's 2n plus 1. Next is what? Lambda d by d. Okay? I hope it's clear. So thank you so much for today's class, students. If anybody is facing any doubt, please ask in the chat box, or else you can leave. Okay? That was all about today's class. Okay, students, if it's okay, you can leave then. Okay.